All right, 3-4. Loan calculations and regression. Should say more loan calculations because we were doing some. One thing that's pretty handy when you're analyzing a loan and loan payments and principal and interest payments is an amortization schedule. Now, of course, every payment you make on a loan, you make your monthly payment. Let's say the payment is $500 a month. Part of that payment is the principal that you originally borrowed, and the other part would be what? The interest that you're paying back to them. And so what happens is any loan, the first payments are always interest heavy, right? So the bank's kind of getting theirs up front, just the way it works out mathematically, and the principal is lower. But as you get closer to the last few payments of the loan, then the interest is lower, right, because you've been paying on the balance, right? So percentage of the smaller number is smaller, and the principal portion is higher, right? So you're paying off the principal more rapidly, paying less interest. And you can make what's called an amortization table or an amortization schedule. If you look on page 173, and I have it up here too. It's gonna act up on me again. Amortization. So it's a table that tracks loan principal as it gets paid down, okay? Table that tracks loan principal as it gets paid down. Right? You go down page 173, you can look up here. I'll bring this other little chart up here. So early on, your payment is interest heavy, okay? Payments are interest heavy. So the payment stays the same, right? And the components that make it up start to change as you pay the principal down, okay? And so again, later on, most of your payment is principal reduction. So if we take a look, let me bring this table up here. No, I didn't do it. That. Yeah. Let's see if I can do this successfully. No. Anyway, look in your book on 173. So this is a particular loan. Looks like probably a mortgage, right? Because it's like $100,000. All right. So whatever loan this is, it looks like they probably borrowed almost $100,000, right? And there's a particular payment. What's the payment on page 173 there? What does it say there?
The loan amount?
The payment amount. I think it's like a box up above this.
Oh.
It's not in this one.
The monthly payment?
Yeah.
1910.
So the monthly payment is 19. Yep. No. It'll be here in the notes. 19. Right? So that's the monthly payment on this. And look at the principal and interest portions of it. Notice that early on in the loan, the principal is $1,451. And as you go down, what's happening to the principal portion of that payment?
Going up.
It's getting bigger. Now look at the early on the interest portion. Your first payment has an interest portion of $458. What happens to the interest as time goes on of that payment? So all the way through the life of the loan, these two numbers add up to that exact payment, $1,910.12, right? But the principal is going up and the interest is going down, just keeping the payment the same. And so as you proceed through there, it starts getting paid down more and more rapidly. If that makes sense, okay? And this is called an amortization. If we get to chapter 7, we'll learn how to make one of these tables. They can be handy for you, okay? What's that? This looks like maybe a mortgage or a house, something like that, okay? All right. Which isn't, a whole lot for a mortgage, 100,000 these days, but, okay? Anyway, so let's take a look at, so what we're going to learn in this section here is, we've covered this amortization, just a brief intro to it, do more of it later if we have time. If you're thinking about taking out a loan, maybe you're approaching this loan, for a car or whatever you want to buy, as how much monthly payment can I afford, right? And so let's say you can afford $100 a month, whatever this loan is, right? Okay. You can decide, okay, things you can change then. If you know your payment's going to be $100 a month, that's what you want. You could change the amount that you borrow, right? Or you could change the length of time that you take out the loan for. So the longer you take out the same amount of money as a loan, the lower your payment is, and vice versa. Okay? So this is going to focus on, like, if I can only pay $100 a month, I can only afford that, how long should I take out my loan? Because you can take out a car loan for 1 year, 2 years, usually up to 6 years, right? You want to try and avoid taking it out longer, though, right? Why would that be? You end up paying more interest, right, the longer the loan is, which isn't really an enormous factor these days, given that rates are so low, money's almost free. But all else being equal, you want to shorten the loan as much as you can. But then say you still have a budget of $100 for a payment, right? So probably the shortest loan to fit your monthly payment budget. So let's take a look at some examples here. There's only 2 of them I think we're going to do in here, so it won't take too long. Let's go to example 1 on page 174.
Yeah,
You hate the formula.
yeah.
Why? It's just a formula. Well, presumably, this monthly payment formula, you got anything else to do? Just work with your regular daily schedule or anything else?
Yes.
Okay. So I'm going to presume that, you've done the homework for the last couple sections, that you know how to use that formula, plug it in, and now we're going to try and investigate something a little further with this, so we'll use the TBM on the calculator to do it, okay?
So y'all learned this formula already?
Yes, well, no one was here yesterday,
Hey,
but
I showed up at that
I'm
meeting.
presuming that you watched the videos and learned it. So example number 1. Hey, Dylan, read example 1, would you?
Determine the total interest owed on a 5-year, $2,000 loan at 6% APR.
Yeah, I would change the word owed to paid, right? But to be paid. So we got the monthly payment formula there. So remember what we do, right? So we got to figure out what the monthly payment is, multiply that by the number of payments, right? And that gives you the total you pay for the loan. And the total interest, how do you get that? Also called the finance charge. Once you figure out what all your monthly payments will multiply out to, how do you figure out how much of that is interest that you pay? No, the formula gives you the monthly payment.
All in times how many months it is.
Right, and that'll give you the total amount that you pay for the loan. But then how do you figure out how much of that is your interest charge, your finance charge? Subtract the original, right? Did a lot of that in the last couple of sections. So instead of using that formula, let's just use our TBM on the calculator. Okay, remember how to get into that? We're going to have the little field that has the N, right? The number of payments.
5 times 12.
What is it? Yeah. 5 years times 12. You can just put 5 times 12 in there if you don't know, right? Yeah. And then the I percent, remember, we don't convert this. The rate is 6%, but what do we have to do to that 6? Because it's compounded monthly. Divide by what? No, if we were using the formula, we would. It's compounded monthly. 6 is the annual rate. Divide by 12. Divide by 12. Divide it by 12 to get the monthly rate. Working here. You got me? All right, and then the present value was how much? 10,000. Okay, and we want the payment. So you're going to go put all that in, and then go down to the payment field and hit the enter key. And what do you get?
193.
Really, what do you get? It's negative, right? One of these got to be positive, the other has to be negative. 193.33. 33. 328, that makes it 33. 33 cents. Round money to 2 decimals. What do they have in there? Yeah. No, they have 33. 193.33. Yeah, they did right after that. Right after it. Okay, so let's figure out.
But I didn't say how.
Well, if the number after the 2 is 5 or greater, you round it up. If it's less than 5.
Can you review that?
Rounding?
Yeah.
Let's take that payment, 193.33, multiply it by 5 years times 12 months, right? And we end up with a total of 11,599.80, I believe. 11, come on, 5, this is really, 99.80. Okay, is what you pay in total at the end of that loan when you're done paying it off. Okay. And did they ask for? Yeah, they did. So to get the finance charge, Dylan tells us we just take that and subtract the original amount we borrowed. So 11. Well, not quite yet. Someday soon, maybe. Minus 10,000 gives you what? Or don't, because you know. Right? So total finance charge or interest cost of $1,599, about $1,600 to borrow that 10,000. Okay. All right. So let's do the check with that. Make sure you guys can do that. Anybody have any questions on this? Yeah. With the check, I would like you to use the monthly payment formula. All right, instead of the TBF. Okay. Use the formula. Use the formula. All right. They have it in the book there. So want to make sure you can enter this correctly with all the grouping and nesting. What is it, 18 times? Yep. Pretty good. Plus 3, 12. To the 8 times 12. That whole mess over. 1 plus 0, 4, 3, 12. 8 times 12. I should have 12 times 8, I believe, but whatever. Minus 1. All right. All right. So 221.93. Okay. But now we need to figure out what the finance charge is. Okay? And how do we get the total amount paid? The total of payments.
How do you do it?
Yeah,
Money?
yeah, right. Or math.
Oh, yeah.
That's our payment. How do we get the total of the payments? The life
Multiply
loan.
number of payments.
Multiplying.
12
Don't forget, times is not a verb.
multiplied by 12.
That's right. 221.93 times 12. How many years was this? 8 years. 8 years. And what do you get? $28. Yes, ma'am. So you get 21,305. 28. So that's total payback on that loan. Now the finance charge, or the total of the interest. Good. We're just going to subtract 18,000 from that, right? So 21,305.28 minus our original $18,000 principal. All right, what do we got? 3305.28. 3305.28. All right.
We try for a better interest rate.
4.3. What did he say he was borrowing? A car? Right now, I mean, this book was made a couple of years ago when rates really started to drop to the floor. It might be a little bit lower now for a car loan. Because rates have gone down a little bit even more. It's unbelievable. I bet interest rates have never been this low in the history of mankind. That's why I keep saying money is pretty much free right now.
Buy.
Yeah. We're going to get to the part where we talked about, okay, you can afford a certain payment. How long should I take this car loan or whatever it is out for? So we have another big, fat, juicy formula. What page is that on? So it's a loan length formula. Okay? Loan length formula. And then I'll show you, and I think we did it once, how to do it with the TBM, right? But the just as I want you to learn to do the breaking first, okay? And we have to be careful when we go back and use it in the TBM, but we'll get to that later.
That's great.
Hmm?
Geometry class.
You thought this was geometry? All right, well, if you want it to be. So time equals log of M, the monthly payment that you can afford, over the principal that you want to borrow, right? Minus log of M over P minus your rate over 12, and we're assuming compounded monthly, right? They're always putting it as 12 in these things, because most loans are monthly payments at compounded monthly. Divided by 12 times the log of 1 plus R over 12. Okay, so this will tell you how much time you should take out a loan payment for a particular monthly payment that you're looking for. Okay?
So whenever I go to get a loan, I should just follow right here.
Absolutely.
Just right on it.
Now, here's the thing, that's not a bad question. Like I sense a little bit of sarcasm in your voice, right? So, like in mathematics, there's certain things that are big and bulky and obnoxious, but that there are other tools we can use, in the world.
Yeah.
Right. And there's also loan payment calculators online, right? But the idea of you guys sitting here in this class is to know where they get this number from. Like, how does it happen? And this is how it happens. Because maybe someday you'll be the one programming your loan calculator on someone's website. Right? Okay, so basically, you're getting to see how the sausage is made, as they say. Right? You've heard that expression? Huh?
No, it's
I say that.
why?
Or have you ever seen, like, in the meat section of the store, the sausage out there, so nice and packaged, and it's delicious, right?
I don't remember.
But if you ever saw it made, you know, it's behind the scenes, you might not want to see it. So this is the big grinder and all that, and this is where all the hooves and beak get ground up together.
I
You
don't
know,
remember which animal produces the sausage.
All of them.
pig, pig. Porcine delight.
So it starts off big, then it makes the sausage.
Yeah, and then they grind some hoof in there. See, there's like, right, this is the grind, you got all the ingredients and the hoof and the snout. That's the log of the snout that gets in the grinder, right? Okay, anyway. Huh? Let's go to example 2. Carly, would you read that?
Claude wants to borrow $25,000 to purchase a car. After looking at his monthly budget, he realizes that all he can afford to pay per month is $300. The bank is offering a 5.9% loan. What would the length of his loan need to be so that he can stay within the budget?
He can afford a $300 payment. So he wants to see how long he should take the loan out for to meet that, right?
I think we should get a cheaper car.
Well, I mean, that's one option, right? I mean, you could definitely reduce the principal, right? But in this case, he wants to say, okay, this is what the car costs, this is what I can afford, right? Maybe he's locked in on those two details, and he just wants to know how long do I have to take it out for. So let's plug all this into the loan length formula, okay? So, it's a big mess. T is going to equal log. His monthly payment M is 300, right? And how much was the car? 25,000. So that's our P, principal. Okay. Minus log this mess here. So we got 300 over 25,000. Minus, I think the rate was 5.9, so 0.059 over 12. Okay. That whole thing all over 12 times the log of 1 plus 0.059 over 12. Okay. And we'll just do it equals approximately. So let's make sure you guys can get that in your calculator.
You think you can do it in your head?
No,
No.
I think I cannot do it in my head. I can do some things in my head. This one's not one of them. And hopefully you get like 8.957 or approximately 9 years. So, it's kind of a weird example, right? Because I don't know of any bank that will loan you, give you an automobile loan for 9 years.
It's not, is it log times this or
Log of that.
log of 300 over?
Yeah.
Why is it hard?
Well, you can't log to make sure that you know it's a log of that.
So you just put them together.
Good.
Why is it parentheses in the front of that log?
In front of this log?
Yeah.
It's on the back side. It's the log of whatever this ends up being. Like you'll do log and then you'll back over that and then close parentheses and move on.
A lot of years to get a car.
Yeah, it doesn't. I don't know if any bank can go 9 years. It used to be 3 years. You know, back I know in the 70s and 80s, like 3 years as far as they go. And then somewhere in the early 90s, banks started going out to 5 years. And why would that be? You're taking the car as collateral. What happens to cars as they age? The value goes down. Therefore, the bank's collateral value goes down, and they're facing more risk, right? So let's say you got a car that's 9 years old, right? And you beat the crap out of this thing, and you stop paying them, and they come to collect, and they're not getting value from their collateral. 6 years is about the max you'll see. What's that doing? Okay. You guys able to get about 9 years there?
Yeah.
No?
Yeah.
Okay. So let's take a look at the check. Read that check there, Simone, will you?
Present to what investor monthly payment of $50.
So we're taking the monthly payment that, the 300, and making it what? 350, right? And we'll see how that changes the time. Payment equals 350. So we're going to use our TVM, and there's something we got to be careful with, okay? So it's that capital N field, right? Because basically that's the number of payments, right? So we got to be careful. So nothing will go. You'll leave a 0 in there for right now. And then the rate interest percent, you're going to have 5.9 divided by 12.
Wait, why do we have 350 per payment?
Because the check says what happens if you increase your payment by $50.
Oh.
The last one. Okay. Present value still 25,000. Okay. And now for our payment. Now be careful. What's going to go in the payment here? What's going to go in the payment field?
350.
Not 350. Are you paying the 350? Is it going away from you?
Oh, negative 350.
It's got to be, remember, one of these got to be positive, the other one's negative, right? The $25,000 is coming to you, so it's positive. The payment, you have to put in negative $350. Okay? And then up here, you go back up to this field and hit the enter key. And what do you get? You will ask them, will you? 88.2058, right? 88.2058, something like that. So is that the number of years then? Is that our T?
Oh, it's lots.
Right, be careful, right? Because what do you normally put in here, like the years times 12, don't you? Right? So if this is compounded monthly, that makes that the number of months. And I'll use a rare exclamation point. Use them sparingly. So how are we going to find the number of years? Anybody want to take that one? Divided by 12, and you get approximately how many years? 7.35 years. So you shorten this long term significantly, right? I just bumped it up $50. Okay? Anybody have any questions on this? You got a new formula? Now we have the TVM, of course, but on the test, it will ask you to use the formula. So make sure you have a note card. Maybe practice entering stuff in it, getting it right. It'll be in parentheses. Okay?